Okay? So here, for any right isosceles triangle, you take the square root of 2 and multiply that by whatever the length of the side is, which is 4. And now therefore you found the length of the side, because the square root of 2 times 4 is equal to 5.6568. Or you can simply say 5.66 or 5.7. Depending on which place you round it to. And there we're done with that, finding the side, the unequal side of a right isosceles triangle. So in words, to find the unequal side of a right isosceles triangle, multiply the length of one of its equal sides by the square root of 2. Okay? Or you can use the Pythagorean theorem, but you're going to get the same number. Because this is a right triangle, a right isosceles triangle, the unequal side would be the unequal side would be the hypotenuse so you get h squared small h, h squared is equal to 4 squared plus 4 squared. Okay? Get h squared equals 16 plus 16, which is 32. And applying the square root principle, we get h is plus or positive or negative square root of 32. And then we can further reduce that. To the square, we can further reduce this. I'll work it over here. To the square root of 4 times 8. Okay? Which then that becomes 2 by the square root of 8. 2 square roots of 8. Okay, but then you can further reduce the square root of 8. See, because the square root of 8 is equal to the square root of 4 by the square root of 2. And then the square root of 4 reduces to 2. Okay? So you end up with h equals a positive or negative 2 square roots of 8, which the square root of 8 is equal to the square root of 4 times the square root of 2. Okay, and that's going to give you 2 times 2 by the square root of 2, or 4 square roots of 2. And then 4 square roots of 2 is going to come out to this value here. But the first method is a lot less work if you know that you're working with the right isosceles triangles, where you simply multiply the length of one of the equal sides by the square root of 2. And that's exactly what you have here. 4 square roots of 2, which what this side is equal to is 4 square roots of 2. Okay? Okay, so following this format and then words, basically you can remember this. This is a right isosceles triangle. Now whatever the length of the sides is, this unequal side is going to be equal to L times the square root of 2. And that's for any right isosceles triangle. Now for the next example, I want to show just sometimes people have trouble, they get confused when calculating the areas for a whole triangle or maybe just a right triangle. You could get confused. Now here, this is an equilateral triangle. We have an equilateral. So we're going to draw a height from one of its vertex to meet the side perpendicularly. That's a straight line, the height h. Okay. Or we're going to say x. We're going to use x for the height. Okay. Now we want to calculate the area. For this triangle. Okay. So the area of a triangle is equal to the base times the height over 2. Okay. So here, so what do we count as a base? So we know one of these sides is the base. But the height is unknown, which is an x. Okay? So in order to calculate the area, we have to find x first, before we can calculate the area. So the first thing we have to find is x, which is a height. And we do that with dealing with one of the right triangles that this forms. So this side is equal to 10. This side will be half of 10. Because remember, whenever we draw a height, if we draw a height in the equilateral triangle, it cuts the base in 2. So here is 10 divided by 2, or 5, and then we're looking for x. Okay? Now simply you could just say 5. And we're going to use this and plug these values into the triangle theorem attributed to Pythagoras. Okay, so 10 is our hypotenuse. So we get 10 squared is equal to the square of x plus the square of 5, or its base. Now to isolate the square of x, we subtract 5 squared from both sides. In which case you get 10 squared minus 5 squared. So x squared is equal to 100